In this video, we are going to see about the recursion and its application in C programming. In C programming, we can say recursion, it is a routine that calls itself again and again. So it is a recursion is a subprogram. That subprogram will be a part of the main program. Within the subprogram, we are calling the function again and again. Also, we can call a recursive function directly or indirectly. So, in simple words, we can say recursion is a function that will be called itself again and again to do the same function. In real time, we have the applications of recursive functions such as calculating the factorial of a number or calculating the value of the Fibonacci series, or in data structures we need to search over the binary tree to find the shortest path. Like this, it has some peculiar applications in real time. This one is the syntax of the recursive function. So we are having a main function. Within that, I have called a function funct. This is a subfunction of my main function, and below that I have written it as the subfunction funct. Within the subfunction, I have called the subfunction again. So funct. So this is where the statement says a recursive function is a function that is calling itself again. Unless we provide a proper break statement there, the function will call itself repeatedly and it will iterate throughout endlessly. So it is very necessary to look into the matter that we have to break the function at time. Recursive function example. So here I have declared a main function which is of an integer data type. So I have written the int return of 0. So within the main function I have declared n equal to 2. N it is of integer data type, so int n equal to 2. Printf %d. The value of %d will be taken up from the function n. So the func of n will return an integer value. So it was stated like printf of %d. So once this function func of n is called, it will directly go to the subfunction fun of c. Here in main function, the value of n it is 2. So int fun of 2. Inside the subfunction n, if n is equal to 1, it will return the value 1. Here the value of n is 2. So the if statement failed. It goes to the else statement. Return 1 plus func of n minus 1. The value of n it is 2. So 2 minus 1, 1. So I have called from the main function func of 2. But when calling func of 2, I need the value of func of 1 here. So func of 1 I need. So again I am calling the same subfunction func of 1. And here it checks the value. If n is equal to 1, yes, my value it is n, 1 is equal to 1, it returns the value of 1. So here I have returned the value 1 to the function 1. Actually I need is return 1 plus function of 1. The value of function of 1 it is 1. So 1 plus 1 return of 2. The return of 2 it is the value of the function called it is function of 2. That function of 2 is called from the main function printf %d function of 2. So the value of 2 will be printed here. So initially I have called the main function. Within the main function I have called the function of 2. So once I call the function of 2, it goes for the subfunction it is checking for the condition if n is equal to 1, so 2 is not equal to 1, so the condition failed. It goes to the else part. So return of 1 plus function of n value, it is to 2 minus 1, the function of 1. So I have called initially main function function of 2. Within the sub function of 2, I have called function of 1. Again it goes for the function of 1. It checks the condition, yes, 1 is equal to 1, so it returns the value 1. The value of 1, it is the output of the function 1. The output of the function 1, it is needed for the function of 2. So the value will be returned to 2. Return 1 plus function of 1, the value it is 1, so 1 plus 1 2. Actually this is the output for the function of 2 that was called by the main function of 2. So the output value will be 2. It is a recursive application. It is the factorial of a number. I have written the program for the factorial of a number. It is as usual, we are defining a header files, integer type function. So int main I equal to 12, factorial of percentage d, it is factorial of I, that is 12 is factorial of I. So I have called of another function here. So int factorial of int I. So int I, here 12 will be passed. It will check whether if I is less than 1. No, 12 is not less than 1. So it will goes for return of I star factorial of I minus 1. So here 12 into factorial of I minus 1, 11. So again the factorial of 11 will be called off. So in this way it will goes iteratively until the I value is less than 1. So in the second part of the slide, I have stated the factorial of 3. That is 3 is the factorial of 3 star 2 star 1. We can say 3 star 2 factorial. Again for finding 2 factorial, it is 2 star 1 factorial. So same concept I have implemented in the program. That is 2 star 1 factorial. 3 star 2 factorial. I need the factorial of 3. For finding the factorial of 3, the 3 multiplied by factorial of that 3 minus 1, that is 2 star. So same concept here implemented. So when we need 3 factorial, I have to multiply it with the number 3 with 2 factorial. When we need 2 factorial, I have to multiply 2 with 1 factorial. The same concept will be implemented. So here comes the application of a recursive program. We can say a recursive application is the breakdowning of a small larger task into a smaller task. From the smaller task we can obtain the solution for the larger task. So for finding the 12 factorial, I need to find the 11 factorial. For finding the 11 factorial, I need to find the 10 factorial. So likewise, once I find the 10 factorial, I can multiply it with 11, so that it will become 11 factorial. So 11 factorial multiplied by 12 factorial multiplied by 11 factorial, the value will be the 12 factorial. So instead of finding the 12 factorial, I am breakdowning the sub values like 11 factorial, 10 factorial. So from finding 10 factorial, I can find 11 factorial. From with 11, I can find the 12 factorial. So this is the basic applications of a recursive function. Thank you.